Wait, so do I? What I have to do to find like the using y and x, and then doing the gradient thing. Or
No, this isn't gradient at all. So you're just finding where they cross over, points of intersection. Any idea about that?
um, so because it's x squared, it hits off like the x-axis. Um, oh, do I just need to make? Do I just need to sub in 12 plus 4x into x squared?
Yep.
Okay, and then that'll be. So, okay, and that'll be 144 plus 96x plus 16x squared.
I think so. This is y equals.
Yeah.
So it would go there. It wouldn't go in for x.
Oh. Oh yeah. Oh sorry. Yeah. So plus 4x. Oh, and then so when I get minus x squared plus 4x plus 12, I just need to put it to the polynomial calculator.
Yep.
Okay, so the x is 6 and x is minus 2.
Okay.
So does that just mean that I need to do sub x the x's into x squared, for example,
Yep.
and that'll be 36 and 4.
So y is 36. So y is 4. And so what are the coordinates?
Um, so the coordinates will be 6, 36, and minus 2, 4.
Okay, and then hence part B.
Um, do I just need to make minus x squared plus 4x plus 12 is greater than 0,
Yep.
and then calculator.
Yeah. See if you remember that one.
So I got minus 2 is smaller than x, which is smaller than 6.
And x smaller than 6. So in the old days, you didn't have it so easy. And this is what they're thinking. So these are the x coordinates from our first one, minus 2 to 6.
Yeah.
They want when is the straight line graph greater than the quadratic graph? The straight line graph is greater than the quadratic graph between here and here.
Yeah.
And in terms of x, that's when x is between minus 2 and 6.
Okay.
Yeah. And they would have, they say use the graph, but it's easier to use calculator. Find the coordinates of this. Okay, how about this one?
Okay, so
No. It's fine. Function, that's okay. let's see, find a set of curves. You'll be fine, I think. So inequalities on graphs.
I think probably a tick.
Just because there's no, I could look for. Hang on a second. How do we do this?
Okay, so is this where my graphical calculator comes into play?
Yeah.
Okay. So I'm still pretty weird with this. So do I just press 5 graph to do this?
Yeah.
Okay. And then so I'm not really sure what to do. It just says like y1, y2, y3, y4, y5, y6.
So put in 3x minus 7. So let's see. So 5. So then you put in 3. Then this x here above the fraction symbol, above the 7. So 3x minus 7 equals, and 3.
So where's the x, sorry?
It's above. It's just here above the fraction symbol, which is above the 7.
Yeah. And then how do you go down, for example, on the calculator?
Press down. That down arrow thing.
Okay.
When you press equals, I think it just goes down automatically.
I don't know where the equal sign is in the calculator.
Or execute, I think it's called. Bottom right.
Oh, yeah, thanks. Yeah. And then we've subbed in all the equations now, haven't we?
So once you have those, F6 for draw.
Exit. Oh, I drew. Yeah, I drew it.
Okay, and let me just say shift, zoom, box. I don't know. I'm not good at the zoom part. Does yours look a bit different from mine?
Yeah.
Does yours look good?
It's got 2 lines crossing over each other, so I guess that.
Maybe it's more like this one. Okay, so you could use this to sketch it. What can we do? Graphical solve. So shift F5 is graphical solve. Let's choose root. If you press equals, yes. So you've got 2 different lines.
I think my lines are a bit different to that.
It might just look different because mine might be a bit more zoomed in or something.
Mine are like this. I don't know why.
I don't believe I. And graphical solve, F5.
Yeah.
And then you can choose, let's say, root. And you can press up or down to pick the different lines, whichever one you want.
So shift solve. I seem to have the same lines.
Did you get the root?
What does that mean, sorry?
Where it crosses the x-axis.
I've got 3. Is the.
Yep.
Oh no. Yeah.
And so for This one, the g of x. So the root is 3.
Yeah.
How about the root for the other one?
3 as well. Or
I
oh,
don't think it is.
no, sorry. It's about. It looks like 2.2 something like that.
So you can actually press again shift, graphical solve, root, and choose that one this time. So shift F5, root. So shift, graphical solve, and then F1 for root, and then you can choose the bottom one. And I should say 2.3 recurring down the bottom.
So sorry. So shift graphical solve, and then where do I choose the root? Sorry.
F1, I think. Shift, graphical solve. Yeah, root is F1.
All that happened here is just it changed. It started changing the color of the line. But
That's just it. That line is selected. So you'd press execute.
execute. Yeah. Yeah. Pressed it.
And does it say down the bottom left 2.333?
No.
Did it say 3?
No.
Did you press execute?
Yeah.
Go ahead, show me on your thing.
So here there's like a flashing line. So
Yes. So press up or down to choose the other line.
it's good. Yeah.
Yep, and press execute.
Yeah. I pressed it, and it's execute. That's this button here, isn't it? Like.
That's like equals down the bottom.
Yeah. Oh, sorry. Yeah, sorry, I did give it to me. Sorry, I was pressing the wrong button.
Okay.
Yeah, I got 2.33 as well.
Okay. So same thing again. Let's do y-intercepts. So shift, graphical solve, and y-intercept F4, I think.
So, okay, so, shift, it just says Y accept.
And then you can press up or down to pick whichever line you want.
Yeah.
So let's say bottom or whatever the first line. Go and press execute.
Yeah.
What is y-intercept?
Y equals to -7.
-7. Okay, so that one down here is -7. How about the other one?
And then for the other one,
So shift, graphical solve, y-intercept, and then you press up to choose the other one. So the other one is flashing. And press execute when you're on the other one.
X equals 0, Y equals 3.
Y equals 3. That's great. So we have the roots, we have the intercepts, and now we need the point where they cross over. And so shift, graphical solve, point of intersection, F5.
Okay. So it says X equals 2.5, Y equals 0.5.
Great. And so that is 2.5 and 0.5. That's the point of intersection. What else was I going to look at? I just wanted to see something. I never saw something before. Sorry, draw, shift, graphical solve. What is that? Is that the area? Root, intersection, mixed. Let's go with intersection. So that's the point of intersection. Oh, I'll look at that some other time. Okay, so the point of intersection, that was part B. We got that, 0.5. Part A was to sketch the graph, and that's what we've done. So we've done the two lines, x-intercept, y-intercept. And then C is this one. How do we do this?
So,
And you can do it just by looking at the graph.
do I just solve for x here?
So you could, but you've already done that. And you got 2.5 as the point of intersection. So that there, the x is 2.5.
Yeah. So, do I just sub in 2.5?
No. So this first one is the f of x. This second one is the g of x. And so the question is, when is the f of x greater than the g of x? When is this red line greater than the blue line?
I don't know, when it's higher than it, I'm not really sure.
Solve it the normal way.
Okay. So I got, oh, x is greater than 2.5.
That's it. X is greater than 2.5. So this is where they're equal to each other. When x is greater than 2.5, the red line is greater than the blue line. It's over it, has a bigger y.
Yeah.
What if they had asked for 3x minus 7 is less than 3 minus x?
So then x would be smaller than 2.5.
Yes, exactly. And so, yeah, so once you have your sketch, you can then use that. Or you can just do it the old way, and both will work. Any questions there?
No.
Okay, and so it's worth putting in the time to kind of plus 3x minus 7. The y-intercept is minus 7. And then you would just make y0 and get the root would be 2 1/3. Same for the other one. When x is 0, y is 3. So that's that intercept. And the root is when the other one is 0. So you just sketch them the old-fashioned way. But for later ones like quadratics, exponential graphs, log graphs, when you know how to use the calculator, it'll be that's when it helps a lot. Okay. Oh, right away it's going to help, I think. Okay, let's try this one.
So I just need to do the calculator thing again.
Yeah, so you can press exit there.
Yeah.
And just change them. Up. Change the first one, change the second one.
And then do I just have to press exit again?
Try it. Yep.
Yeah.
So mine might look a little different from yours. Okay, what could you do next?
Any more points proposed to the coordinates?
So we have to, sketch it. So what can we sketch?
So do we just have to draw the graph and then just sketch it?
You have to, just sketch those two graphs. How do you do that?
So so do I just have to draw an x-axis and a y-axis?
Yep.
And then 9 goes on the x-axis from like -4. Well, basically just from 0 to. I'll just say from like -4 to 7.
Basically, just sketch what's on your calculator screen.
Yeah.
So maybe it's a bit like that.
Yeah.
Okay, what do you have to include in your sketch?
Where it intercepts at the y-axis,
Okay, find those.
and then I need to do. So for the curve, it intercepts at -12.
Okay, great.
And then I need to do it for the other line now, don't I?
Yep.
Right, how do I go back when I've just found that? Sorry.
No, what's wrong with my thing? Yeah. To go back, let me just check. So shift, graphical solve, y-intercept. Okay. You can press exit. That'll work.
Yeah.
Maybe that's too much though. No, I think you just do it again. So just press shift, graphical solve again. Solve, y-intercept. Yep. Yeah, then just press shift, graphical solve. Yes, you don't have to. Y-intercept, and then press up or down to pick the other one.
Right. And then I got the other one. So the straight line is y equals to -7 as y-intercept.
Yep.
Yeah.
Okay, what else do you need?
And do I need the 2 points on the x? Or no, all 3 points on the x-axis.
Yep.
And so that looks like 2 and 6 for the curve.
Yeah.
And then for the straight line, 3.5.
Okay, that's great. 3.5. Those are 2 and 6. I think it would be good to find the maximum for the curve.
Okay.
Coordinates of the maximum.
Okay, so the maximum. Then I can pick which one I want to do the maximum for.
Yeah, but it would have to be the curve.
Yeah.
The line will just go forever.
Oh, yeah. It says the maximum is x is 4, y is 4.
So 4, 4.
Yeah.
Great. I think we have, that's like full information for the sketch. And for the curve, so shift graphical solve root. If you pick the curve, you can see it has 2 for that one, and if you press right, then it gives you the other one 6, and so you can just keep swapping between the two. So you can just verify. It looks like it's 2 and 6, but you can just verify that by doing it, and it'll press left and right to get the two different roots, and it'll tell you x
Yeah.
equals 6 there. Great. Part B, points of intersection.
Okay. So there are 2 points of intersection, aren't there?
Mm-hmm.
And I think the points of intersection are 5, 3, one of those.
Okay. Do you know how to get the other one?
I just need to keep scrolling down until I see what it looks like.
So that's the 5, 3 one. So did you do shift graphical solve?
No, I just looked at it and said, yeah, that's 5, 3.
Oh, okay. So you can do shift, graphical solve, and intersection. F5.
Intersection, yeah. And it says the intersect is 1 and y equals minus 5, yeah.
So 1, minus 5. And if you press right, it will verify that the other one is 5 and 3.
Yeah.
Yep, there we go. And then how about C?
Okay. And then can't just put that into my calculator.
You could. 1 mark question. Should be able to do it just by looking at it.
Oh, right. So will it just be 86 minus 10? Yeah.
So when is the blue
So
curve greater than the red line?
will it be like 5 is greater than 3 or something? Or
So just by looking at it, like where is the curve greater than the line?
at 4, 4.
Yeah. And so where does it start being above it? Where does it stop being above it?
So it stops being above it. It doesn't have to be above it at 4, 4. Or
So it's definitely over here.
Yeah,
It's still over for a while. When are they equal to each other?
when they cross.
Yes. And so that's one. Then if you're going the other way, any further and it'll be underneath it. And then the other way?
Yeah, will that be like the other the other place where they cross as well, where they're equal?
Yes. And so how could you describe that bit?
So is that just the intersection?
So this would be like a range of values.
Yeah.
And any idea how to describe that?
Um, do I need to say like x is greater than this or something, or
Uh, yeah. Let's say when x is between something and something.
will it be like so five
Yep.
1 minus 5? Oh no, or more. Sorry, 1 is smaller than x, which is greater than 5.
Yeah. And the two arrows go the same way. And if you put this into your quadratic solver, that's the answer it will give you.
Okay.
If you're stuck, you can do that. But yeah, basically it's above it, between the 2 points of intersection. So when x is between 1 and 5, and that's how you do it. Great. So let's see this thing. Yeah. So you're given two functions. Sketch them both. Label everything. X-intercepts, y-intercepts, maximum, and points of intersection. And then you can just use that to do the last bit, or you can put it in your calculator. Any questions there? Okay. Graphs. Not easy. Okay, yeah, here we go. Now we're talking. Solve the equation. Sketch the graphs on the same. Use an algebraic method. Okay, use an algebraic method. Let's see. Okay, let's try this one.
So so is that just x squared minus 3x minus 10 equals to 0?
Yeah.
And then it says x is 5 or x is minus 2.
Okay. And let's see. There you go. Equation. Okay, part B. And do you know where the quadratic solver is on the graphical one? -2. So that one's just menu and equation. So same place, A, and then you just put them in. Okay, part B.
Okay, so if it says y equals px and y equals qx, does that mean that p of x and q of x are equals to each other?
At the point of intersection, they are, yeah.
Oh, I should solve this into the graphical.
Yeah.
So, okay. So I've got like a big curve.
Okay. Oh, syntax error. What did I do wrong? I don't know. 7 over. Okay, so find the different values. Oh, it's this x. That's what it is. That's 3x. So what else do you need? What do you need to say?
So do I now need to do like shift G solving whatever?
Yep.
And then I need the y-intercept, don't I?
Yeah.
Okay, so for the straight line, the y-intercept is minus 15.5,
Okay.
and then for the curved line, the y-intercept is minus 10.
Okay.
And then I need the interception, don't I? Like whether it cross.
No, not yet. They want where they. So you found the y-intercept. So they want where they cut the coordinate axes. So we found where they cut the y-axis. So what do we need next?
So I don't need an intersection.
No, not yet.
Do I need the x-axis or?
Yeah, you need the roots where it cuts the x-axis.
Okay. So root is the first one, so f of 1.
Yeah.
Okay, so for the straight line,
4.4 or something, is it?
yeah, 4.43.
Let's say 4.43.
So is that that's the x-intercept, isn't it?
Yeah.
Okay.
It's called the root.
And then for the curved line, the root is minus 2.
And the other one?
So the straight line is 4.43.
Minus 2 and press right.
Oh, so that's 2. Okay. So minus 2 and 5.
Yes, and that's what you found in the first one. X is minus 2 and 5 for the when y is 0. And that's what that y is 0 on the x-axis. So if you were doing it the longer way, you would let y be 0 and you would solve it, and those would be your two roots.
So the curve has 2 roots and the straight line has 1 root.
Yeah, so you can see here the curve crosses the x-axis twice.
Yeah.
But the straight line only crosses the x-axis once.
Okay.
Okay, how about this one? C. It says use an algebraic method.
So do I now need to do like 7 over 2x minus 31 over 2 is equals to x squared minus 3x minus 10?
Yeah.
Or so I've got x squared minus 13 over 2x plus 11 over 2, and so I got x as 11 over 2 or 1.
So x equals 11 over 2 or x equals 1. Is that full marks?
No, because I need to find probably y, don't I?
Yeah.
So, so now I need to sub those two x's into one of the equations to get y.
Yeah.
And so, okay. Shall I say what I got?
Yeah.
So I got, so shall I say it in coordinates?
Yeah.
Okay, fine. So 11 over 2, 15 over 4, and 1 minus 12.
So you can do graphical solve and intersections. Yeah. So 1 and 12, and then press right. 5.5 and 3.75. Yeah. Great. And they asked for a algebraic method, so we had to show it that way. And then how do we do part D?
Is this where I need to get the intersection, or?
No, we just got that. When is the p of x less than the q of x?
Do I need to get like the maximum and the maximum stuff?
No. When is the blue line less than the red curve?
So I'm not sure.
Where is the blue line lower than the red curve?
When it crosses the x-axis, I guess.
So here it's above the red curve.
All right. Well, like in the intercept,
So,
like above interception. Sorry.
so that's when they're equal to each other. So it'll be everywhere to the left of that. So
Yeah.
that's always going to be less. Any other place? So here it's less. So here p of x is less than the q of x. Then here the p of x is equal to the q of x. Here the p of x is greater than the q of x. Here p of x is equal to q of x. And so where else is the p of x less than the q of x?
Will it be going left again from there or something?
It'll be going right like that. So if we continue on,
Yeah.
here the blue line is less than the red curve.
Yeah.
And so how would you describe this one?
Do you want to say coordinate here or something?
So we have the coordinate. It was 1 and minus 12.
So I should say 1 minus 12 is smaller than 11 over 2 is 15 over 4 or something.
So in terms of x, so to the left of 1, so it's when x is less than 1.
Yeah.
And then how about this one?
Oh, so and then is that 11 over 2 is greater than x? Or x is smaller than 11 over 2?
When x is bigger than 11 over 2.
Yeah.
So it's going to the right. And if you were to, so p of x is this, q of x is this. If you were to put that into your calculator and solve it, you would get the same two answers that we just got. This one wanted set notation. So you just have to do a little extra thing. Put it in curly brackets and have x such that on the outside. And that's set notation.
Okay. Is that the answer?
And so that's the answer, yeah. So when x is less than 1 and when x is greater than 11 over 2. Okay. That's when the thing is like that. So remember we did this thing earlier, the quadratic.
Yeah.
So that one, if I do it instead as an inequality, and for this one it would be less than 0. X, so a is 1, this one is minus 13 over 2, and this was 11 over 2, I think. No, maybe I put those in wrong. Oh, 13.2, no, 10 over 2, there we go. Between, I put the sign in wrong. It is greater than, menu, menu 2, what did I do wrong? Menu B 2, it is greater than 1 13 over 2 minus 13 over 2. And there we go. X is less than 1. And if you flip that around, you get x is greater than 11 over 2. And you just put the curly brackets around it, x such that. So if you were to do it the algebraic way, we would do our quadratic again, except just with less than this time. And you get the same thing. Or you can just do it graphically. Any questions there?
No.
So that looks like the hardest exam question for that stuff. Let's see. We didn't. That's differentiation. This one is regions. Let's see. Shade the region comprising all points. These inequalities. Yeah, tricky stuff. Let me just see something. This was 3.6. 3.6. Inequalities on graphs. That's what we did. So 3.7 is regions. Regions are very similar, where you just have to say yes, like what region is the line greater than the curve, and so it would be this region here. So for all these coordinates in here, the line is greater than the curve because it's over it. So you would just sketch the two and then shade it in. And I think, there's no exam questions for that. Let me just check. They have one. They have some. There's some way to do that in the calculator as well to get the region. Let me see. Region. I'd have to look it up maybe. Shift. Graphical solve. I don't know. Draw. Shift. Sketch. I don't know. I'd have to look it up. Let's get a region anyway. Let's just take a quick look at what we did. So these were a different time, was it? Yes. Let's see. So if you have to find points of intersection, how do you do it?
So shift, graphical solve, and then in F5.
Yes. And how about with an algebraic method?
So
if you didn't have your graphical calculator.
Do I just need to make the two equations equals to each other?
Yeah. The point of intersection is where they're equal to each other, where they cross over. So you make them equal to each other and just solve it the normal way. If you're stuck with this bit here, like when is the line greater than the curve, that's in between -2 and 6, in between the 2 points of intersection. If you're ever stuck with that bit, just solve it the algebraic way.
Okay.
Especially with inequalities, seems to be easier. Those are okay. This one, these are the regions, is it? I changed it to a different one. So I had this one. This is, where was it? I put them at the end, that's why. I had this stuff. I had it already. There you go. Let's see. So sketch the graphs. Yes. How do you sketch two graphs?
You put it into the graph thing in the start.
Mm-hmm.
And then into graph function, you put into y1 and to y2. You just sub in the two equations and you press X or EX works. So I'm not really sure how to say it.
Execute, like you assassinate or whatever.
Yes.
And then what more information do you need for a sketch?
Like y-intercept, x-intercept.
Yes, those are the main ones. And I just also put in the maximum, but they didn't ask for that. And then you can get the points of intersection, yes. So these sketch points of intersection, and then if you're not sure about this bit, like when is the curve greater than the line? It's greater than the line between the 2 points of intersection. So between when x is 1 and 5. If you're not sure, just put that bit in the calculator algebraically. Set notation is same thing. So you can just solve it using a calculator. It gives you that answer. Let me just see. So that was this one. x is less than 1, and you flip it around, x is greater than 11 over 2, which you can see there. The curve is, or the line is less than the curve when x is to the left of the first point of intersection, to the right of the second point of intersection. And then just put curly brackets around it, x such that, and that's called set notation.
If they don't ask you to put set notation, but you still put it, they'll still give you full marks, won't they?
Yeah, they will.
So it's better to just put set notation every time, basically.
Yeah, that's a good point, actually. I didn't think of that. And yeah, that's that one. How was that for you, Andrey?
Difficult, but I'm sort of getting it, to be honest. So yeah.
It is difficult, and that's why I left it until you have your graphical thing. It's much more difficult. Well, it's much more time consuming without the calculator because you have to manually solve everything, and it's easier to get x-intercept, y-intercept, with that. If you want, we can do the quadratic regions. So that's another thing that I skipped over.